Okay. Now I am recording the session. Okay. Today we are starting part programming. Part programming is related to CNC machines. So this is the content we are going to discuss in this class. 2D, 3D machining. We have already discussed in unit 4. I will refresh what is 2D and 3D machining. Introduction of part programming and types. Milling machines using G codes and M codes and cutting cycles. So these two parts we shall discuss in the next section. I mean the second lecture will be focusing on these two. This PPT contains the font shown in red color. Okay, 2D and 3D machining, you can see. So this picture we have already seen. And 2D machining, what is the thing is, the table, a CNC table will be moving in X and Y direction. In addition to that, the tool will be moving in Z direction. Sometimes it will be stationary. So in order to make a two-dimensional component, we need to have minimum three axis. Okay, in case of three-dimensional machining, we may require minimum 4 plus axes simultaneously moving, so that we could be able to make this kind of complex shapes. Okay, CNC part programming, I am straight away going to the code. So it consists of, it's a set of codes, consists of alphanumerical value. Okay, so here this n is referring to the line number, program line number 02. So the numbering need not be starting from 01, 02 like that. You can give the most of the professionals, they will be giving 10, 20, 30 like that for easy understanding, for easy recognition. So this is referring to the line number. G00 is rapid movement. Supposing my tool is presently here, I wanted to move this location. Okay, it will take the shortest route without cutting highest possible speed. So that is what rapid movement. 00 is referring to x value is 0, y value is 0. Means reference point, the tool is moving. That is the meaning of this one. So it is a alphanumeric expression. Okay, depending on the nature of the job, we will be choosing the machine tool. It may be milling machine or machining center or any conventional machine tool you can choose. The function of this programming, it will give you the direction, movement of the machine tool, not movement, the movement of the CNC table, you can say CNC table, sometimes tool also, CNC table and tool. So the movement means it can be in X, Y, Z directions or rotations. Rotation with respect to X, Y, Z also, or simultaneously all these three functions. Okay, movement of the machine tool, it will give the instructions. And some of the miscellaneous functions or auxiliary functions you have to, operate while doing machining. That is spindle rotation, coolant on, off, etc. So manual CNC part programming, which tool is required. So for particular operation, which tool you need to invite for a operation, that you can choose. That code is known as a T codes. T03 means tool stored in location 3 will be performing the operation. So automatic tool changer will choose tool stored in location 03. This tool selection command, it is available that we have to invite the required tool for the operation. Next, cutting conditions. Cutting conditions, speed, spindle speed, say 100 RPM, 2000 RPM, 1500 RPM, that you can set. Feed rate also, mm per minute or per revolution, you can write. This is what the feed rate, coolant on, off, etc. This command you can give. And starting point and ending point of the motion, that we can give. So how to move the tool with respect to the machine, that is also we can give. So for this, we are having different interpolation. So linear interpolation, circular interpolation, cubic interpolation, etc. So depending on that interpolation, your CNC table will move or the tool will move, so that the required operation can be performed. So here, steps involved in the development of part programming, it is process planning, access selection, tool selection, cutting process parameters planning. So you have to choose appropriate cutting process. See what depth of cut you have to give and what feed you have to move the tool. These are all comes under cutting process parameters and job and tool setup planning, machining path planning, part programming writing. It is the manual part programming, so that you have to write the program. In computer assisted part programming, your computer will automatically generate G codes and N codes. For this computer aided CNC part programming, I will share you a video which I have generated in CNC machine tool, some 5 to 6 minutes video that I will share you. You can understand how the computer generate G codes and M codes. Okay. Here the last one is part programming proving, means once you have generated the code, you have to validate whether you. So I am planning my tool has to move like this, one straight, then like this. This is the movement of the tool. I am planning. So I am generating the code also. I need to check whether the machine tool is following the same path or something different. That I have to verify. So in computers, the simulation is the option. Simulation is the option that will give you, you can verify your movement of the tool. Okay, that can also be done. So once you have done, these are all the steps involved in making part programming. So this is the diagrammatic expression which shows the various steps what we have discussed in the last class. Means last slide. If you see here, once you wrote a program, you tested the program, the simulation part is okay, then you can send it to here, machine tool, and you can save this as a program. And this program can be invited whenever the particular part is machined on this machine. Now, if testing it fails, suppose any one movement is not as per the requirement, you have to correct the program. You have to correct the program, you have to change the parameter, etc., so that you can do it. Here, information needed. What are all the information needed for a CNC machine tool? First one is preparatory functions. What are all the preparatory function is what units we are going to use. Unit in the sense whether metric or CGS. Metric in the sense you will be writing mm. Metric inches means it will, the length will be measured in inches. Okay, so these are these value. Whether the movement is incremental or absolute, that also we have to give. Coordinate values x, y, z, rotation about x, y, z, that you have, that is required for CNC machine tool, and machining parameters, feed rate, spindle speed, that we have to define. Coolant, under which condition you have to switch on the coolant or lubrication, you can say on and off, that you can give. Tool control, which tool is required to perform the particular operation, that you can choose by using T command. T02 means tool stored in location 2 will be called in and the operation will be performed. And the tool parameters also we can define. Cyclic function. What cyclic function is? Suppose I wanted to make 4 different holes in a job. Okay, this is my job. I wanted to make a hole here, here, here. Let us take this simple example. So here I can move my tool. I can perform the drilling operation here. Okay, by setting appropriate feed rate, rotation, RPM, etc. I can perform this hole. Okay, once this part is over, I need to perform the same operation here and here. So in this case, feed rate RPM set for this particular tool will be automatically taken by the controller, and I will be giving you the position of this point. Okay, XY value of this point I can give, so that it will move to this location and automatically this drilling operation will be performed for a preset feed and RPM. That is what known as cyclic functions. Okay, this is a cycle. Next, I will be giving X1 coordinate of this one. Here, another drilling operation will be performed. Okay, the miscellaneous control is spindle on, spindle off, direction of rotation. Whether spindle need to rotate in clockwise or anti-clockwise, that you can define. Okay, these are all the information required for writing a CNC program. So here, this the sequence number, feed, everything I have discussed in the previous slide. Here, the another one is dual programming. What is dual programming is, suppose I want to do milling of this. This is my workpiece. Let us take, this is my workpiece. Okay, here I wanted to cut a punch. Punch in the sense, my objective is to make a job like this. Okay, The making whole is not objective. I wanted to make this one. I need to cut this one. This part I will be taking it out. Okay, this is my objective. So for this, I am making a program like this. Initially, my cutter at this location, it will be moving here with certain feed rate. Means CNC table is moving. It will be moving like this, and this cutting is done. And I am moving here so that this part will be still attached with the workpiece. Now I wanted to perform finish operation. Finish. Finish cut I wanted to do. So first cut is rough cut, that is over. I wanted to do finish cut at this region. Now, once this part is over, I need to invite some new tool. So finish tool, for instance, it is an example. Okay, finish tool I want to invite from the tool. Automatic tool changer has to bring the tool, and the feed rate for this will be somewhat different. That I need to give manually. For instance, for this particular machine, I can give the input factor manually. Okay, for most of the unconventional machining processes, this will be the procedure. In case of CNC machine, everything will be done automatically. The input value for unconventional machines given manually. So that case I am incorporating here. Okay, so this input value I need to give. For this, after cutting this, my tool has to be waiting here for some time. For tool change and parameter change, it has to wait. Say 40 seconds or 2 minutes, depending on the profile to be cut. It has to wait 2 minutes or 3 minutes. So this waiting time, the duration for which the CNC table will not move or the tool will not move, that is known as dwell programming. Okay, waiting time is given itself. Once after the wait, during the waiting time, tool will be changed, the parameter value will be set. Then by giving minimum offset, it will be moving like this in this direction. So finish cut will be performed. Okay, once this part is over, this will be cut again, and the finished component is taken away from this job. So this is known as dwell programming. The code associated with dwell programming is G04, which is referring to dwell. Okay, duration you can give. Next is tool length compensation and diameter compensation. I will be explaining in the next slide. So this is the one block format. The first one, starting with letter N, is referring to the sequence number or line number, you can say. It's a sequence number. It can be started from 1, 2, 3, you can do, or 5, 10, 15. So this is also okay, you can give, okay, for identification of the line. So this is preparatory function, G90. G90 is absolute coordinate system we are going to use. And G1 is linear interpolation. Line, the cutting will be taking place in a line. It's a linear interpolation. Dimension words, X value, Y value, you have to give. If required, Z value is also you have to give. The feed rate defined here. So mm per revolution or mm per minute, or inches per revolution or inches per minute, whatever value that you need to give. Feed value you have to give. And spindle speed, spindle rotation you can fix. In this case, spindle speed 1500 rpm. Tool function, so which tool you are calling for the operation, that is given by T code. Miscellaneous function M3 is actually spindle stop. Okay, spindle stop. Okay, spindle on, off, or spindle rotation. Sometimes it's all depending on the program you have to give. Individual word explanation. Okay, so the programming key letters, the letter O referring to the program number. N is sequence number, G is preparatory, XYZ coordinates, R is radius, R is referring to radius, F is feed rate, S is speed, H is tool length offset designation. This I will explain in the next slide. D is tool radius offset designation. This will also I will explain in the next slide. And this is tool designation, tool number. M is miscellaneous functions. Okay, so some of the important G codes shown in this slide, you have to remember all these codes. Particularly this one, linear interpolation, rapid travel, circular interpolation clockwise, this is anti-clockwise, this is dwell, and here planes in case of 3D programming, and you have to define which system you are using, inches or metric. So G20 or G70 you have to use. Both are referring to ingest system. Okay, and tool compensation values, and here absolute dimensioning, incremental dimensioning. These are all the items you have to all the values you have to remember. So this is required for writing a program. So now G00 rapid positioning means whatever be the location, instant my tool is here. For instance, my tool is here. Okay. If I am giving G00 means immediately it will go to the reference point. G00, I am asking that this is 5, 10, G00, X5, Y10. If I give, rapidly it will move to the here, highest possible speed, because no machining is taking place during G00. Next, linear interpolation. What is linear interpolation? Is some machining operation is performed at the set feed rate, this movement. This is you have to define by G01. Okay, G01. This is the starting point. Supposing this ending point is 3, 8. I am giving you an example. 3, 8. G00, X3, Y8. If you put, okay, in the linear fashion from the starting point, the tool will moves from starting point to end point in a straight line. This is G01. Circular interpolation, depending on the information, it will make, see, if I am moving like this, okay, this is my profile. For example, consider this is my profile. So I am moving here. This is my starting point. Tool is moving in this direction. Okay. When you are moving like this, you have to check whether it is clockwise or anti-clockwise. This will be the movement. In this case, it is clockwise motion. If it is clockwise, you have to choose the code G02. G02. This will be the clockwise interpolation. Supposing I am moving from here. This is my initial direction, initial position of the tool. I am started here, moving like this one. In this case, this will become anti-clockwise. If I am moving from this direction, I have to use the code G03, not G02, because it is anti-clockwise rotation. Okay, this is the usage of the G codes. And dwell, I have already explained. The duration, during the time, the movement of CNC table is not allowed, or the movement of the tool is not allowed. And this is various planes in 3-dimensional machining. It is required. XY plane is given by G70, and this is YZ plane. This is Y. This is Z. So YZ plane. Sorry, XZ plane. This is X. This is Z. XZ plane is referred by the code G18. G19 is YZ code, YZ plane. Okay. So tool compensation, what we are discussing in the previous slide, I can explain little elaborate. Okay. So this is actually the pocketing. Let us assume the dimension of this pocketing or this die is 50. Here it is 50. Here it is 50. Okay. It is a 50 × 50. Understand? And I am assuming that its diameter of the tool is 10. It is an example case. Okay, diameter of the tool is 10. I'm referring 10 mm. Okay, now this is my workpiece. What is this? Outline. This is workpiece. Okay, this is workpiece. This is my I have to do packeting along this area, right? So while you are making code, CNC code, the program is made for the center line of the tool. Center line of the tool. Okay, you follow it very carefully. So this is a center point of the tool movement. Okay, if I am using G40, compensation will be cancelled. If I am not inviting G41 and G42, what happens? Let us see. Okay, now I am interested in making 50 × 50 packeting. Okay, this will be the movement of the tool. My tool will be initially here. Let us take, this is what my tool. Okay, initial location. What about its diameter? 10. It will be moving like this. It will be moving in this direction. Understand? My cutter is moving in this direction so that I can able to make a packeting operation. Now, if you watch this tool movement and you tell me what is the diameter of the packeting. My objective is to make 50 cross 50. Since it is moving through the center point, now here some 5 mm added, here some 5 mm added. Therefore, instead of making 50 cross 50, my objective is to make 50 cross 50 size packet. I will be making, what about this? This is 50, from here to here 50, here 5 mm, here 5 mm, you have to add it together. Therefore, I can make 60 cross 60. Understand? So, in order to avoid this kind of thing, instead of following this point, I can define a point like this. Tool path I can take. If I give tool offset option, which is offsetted 5 mm, left or right. This is right offset. Okay. Why I am saying right is, if you are moving along this direction, if you are walking on this line, this offset is right hand side. Okay, this is your face is facing towards this arrowhead. This will be the right hand side. In this case, you have to invite this one, right hand offset, G42, we have to call. G42 means you can make a program for the profile like this. You have to invite G42 and give offset value as 5. So that while the machining is performed, it will not follow this path, it will follow this path. So the cutter location will be like this. Now cutter location will be here, cutter location will be here. Okay, now distance from here to here will be 50. You can have the exact dimension. This is the advantage of using tool radius compensation. If this is not required, you have to invite this then you have to put G40. This will cancel the option. Okay, so depending on the part to be machined, whether it is a die or punch, depending on that, you have to choose tool compensation, right hand or left hand. Okay, this is one way. The another way it is required is, I am using a tool for 6 months. What happens? Some portion will be, some wear happen. Because of that, the dimension is reduced. In that case also, you can invite this and you have to give the tool radius compensation as per the wear dimension you can have, so that you can get a perfect the required dimension of the job. Next one is tool height compensation. What is tool height compensation is, there will be a machine tool. Let us take, this is a machine tool holder. We are going to fix a tool here. See, this is one particular tool I am referring to. The another tool, this is the position of the tool holder. The tool length will be different, somewhat different. Okay, because the all tool movement are automated. Okay, this is another tool. So in that case, my job height is this. You can fix the job height. Okay, with respect to this, if you are defining this value, supposing if we are using this tool and this tool, the depth of cut given will be different, because from the reference this length is different. Okay, so this length can be compensated by using this positive compensation, tool height or tool length compensation. This is negative tool length compensation. If you don't need any compensation, you have to invite this one, G49. Okay, this point I have explained in the previous slide. G40, G41, G42. Tool compensation right, left, and no compensation. Okay, so here tool length compensation, if you look at G43, what is G43? Positive compensation. Okay, G43, G44 is negative compensation. HXX, this X is referring to memory location. Okay, so in this memory location, you have to store the value. Say here I can say that 1 mm. Compensation value is 1 mm. So this XX is referring to the memory location. H01, you may store the value 1 mm. This is for instance H23. I am referring. It may be referring the value stored in the location 23 may be 2 mm. It depends. Okay, the value stored is different. We are indexing the memory location. Okay, so these are all the various tools. From the reference, length is different. Okay, so that this is required. So real position, if you are inviting this 43 positive compensation, real position will be specified position plus value saved in this. Negative compensation is minus value, the value stored will be minus. Okay, so this one I can explain it here, the compensation you can see. So for instance, I am having a job, this is a job, I wanted to perform drilling operation. Okay, so my drill bit initial position will be here, initial position will be here, it is my drill bit. Okay, so here for the actual position is here, a little bit actually at this location. I am moving it rapidly and I am keeping it very closer to this. I wanted to keep it here. Okay, this is one option. Once after drilling, I have to give Z value. Say this is 10 mm. This is 10 mm. If I give Z value is minus 10, it will move up to this. Okay, once this part is touching here, 10 will be over. I wanted to more. In that case, I have to use this one, G44. In that case, minus 10 minus 1 means minus 11. I can make a through hole. Okay, depending on the position, the set value, we have to take tool length compensation, positive or negative. So the ending, finishing of the drill, I need negative compensation. Okay, you can make a through hole. If it is positive, what I have to do is the initial movement I can, this is initial reference, I want to keep it 1 mm distance. Okay, in that case, so this is also negative value, this is also negative value, I have to keep it so that I can maintain this 1 mm. Okay, so this is the advantage of using tool length compensation. So this diagram is also explaining this. This part already I have explained in the previous slide. H01 is the memory location. In this location, it is stored value is 1. Z value is 1. Okay. Okay. Next one is canned cycle. This is also I have explained. Here, my objective is to make 4 holes in the workpiece material. I am moving, this is the reference, actually 0, 0, 0, 0, this is my reference. I have to move my tool to this location by giving xy coordinate of the center point here. Here, what is x value? X is 0.5, y is minus 0.5. Okay, its center point is x is 0.5, y is minus 0.5. Here, once my drill bit reaches this location, I have to set the feed rate and speed of rotation that I have set. And depth of cut also I have to give. If you look at, this is not a through hole, it is partially hole. It is not a through hole. 0.375 is the depth of cut, or Z value you can say. Z value 0.375. This value you can set here, Z value, and feed rate, mm per minute or mm per rotation, you have to set, and speed of rotation of the tool is also set. Now, as per the Z value, it will make a drill. So drill will move up to this position. Once it is over, it will be moving up. What I am doing next is, I am inviting a circle, drilling cycle. G81 is a drilling cycle. It will invite it. I have performed a hole, I mean drilling operation at location 1. Now, location 2, I will be giving the center point of 2 only. Once this is over, see, G81 I have invited, G81, okay, X 0.5, y minus 0.5, so required feed rate is also you need to set. It is all set, let us assume. Okay, so as per feed, as per depth of cut, the operation is performed here. Next, what I am going to do is, here I will be giving x value. What is x value up to? 1.5. Okay, here 0.5, here 1, 1.5. Y value I can this is actually the same value, no? The length value for same. So I need not write. Or I can give y value as minus 0.5. In this case, the controller will move the tool to this location and the operation is performed because it is in cycle. G81 means cycle. Once this part is over, I will be giving xy value of this. X is 1.5. Here I will be giving y value of 3. What is y value of 3? 1. Here 1.5 minus 0.5. If this command will recognize that the tool will be moving to the center point of this 3 and the drilling will be done. I am not setting any other value. Okay, for here, for fourth location, I have to give the x value and y value. Here, x value will be 0.5. What is y here? What is y here? So sorry, here in this case, it is minus 1.5. Minus 1.5. Okay, so once minus 1.5 is already set, I need not give. In this case, the controller will move here and drilling operation will be done. Once the drilling is over, then I have to move G00, means rabbit movement to any location. I can move the tool away from the job. Say it can be X20, Y20. It will move away. Then you can remove the job. So this is the advantage of using the canned cycle. Okay. Otherwise, sometimes this is not required. You have to stop drilling. So the drilling cycle you can cancel by writing G80. Some syntax may be there. Okay, either you have to go for this or any other rapid movement you can give, or G8 cancel cycle you can give, so that this cycle can be cancelled. So this is the advantage. So every time you did not give feed, speed, etc. So this is drilling cycle. So next, G98 and G99. G98 is used tool to return to its initial level. Means that if you fix the tool, this is the tool holder. I am fixing it here. This is the original position. Okay. Okay. This is the original position. This is the reference position. Means my job is here. This is the initial position. I have made a hole here, and while returning, I have to return to this place or this place. That is defined by this. Okay. For flat surfaces, people are referring to this. This is a, see, I have a job like this. Assume this is a horizontal line. I want to make a hole here and here and here. I can keep my tool reference point. This reference point may be 1 mm away from the surface. It is very less value, 1 mm away from the surface. So every time I can move and perform the operation. Suppose my job is like this, here like this, one step, like this. Okay, in this case, the reference will be different. Okay, this reference 1 mm is same, but if I have made a drill here, next my drill bit has to move to the original position. If I keep it closer, I cannot move here. It will hit the tool. Therefore, depending on the profile, you have to use G98 or G99. In case of flat surface, you can use G99 because this movement time is reduced. Therefore, the machining cycle, duration of machining will be lesser. Maybe a fraction of seconds. One component you may save, say 5 seconds or 10 seconds, you can say. If you are making 1 lakh component, you count the time. Okay, so for every job you will be saving 10 seconds. This because of this movement, 10 seconds you can save. So for 3 shifts, number of component is 1 lakh. The time saved will be very huge. Okay, therefore, depending on the profile, you have to move the machine tool, the tool, either to the initial level or to the reference level, very close to the job. Okay, these are all the some of the important M codes. This one we can discuss in the next class. I am stopping here. So I am